So MongoDB is a database where you can store different JavaScript objects, like blog posts, contacts, accounts, whatever you want, inside of the database, query it, query meaning read it from the database, and so on. What you can do is we can use MongoDB for free online. So there's like a service where you can sign up, you get your own database instance where you have like 2 gigabytes of free space, which is more than enough for us to build our apps, play around with them, learn MongoDB. Basically, this is how you would use. This is how I use it daily in my work right now. 3 years into it, like as a professional developer. So I'm literally teaching you exactly how you can do it as well, the way I do it in a way in my own day-to-day work. So we also use this service. So if you go to MongoDB sign up, you don't have to have a company. You can put your own email. They say work email. You can put whatever Gmail you have, first name, last name, password, whatever. And then, because I already have my database, you can just follow these steps. So you can fill in the sign up details, put whatever organization name you want. I added learning for my project name. So if you go here to my database, my project is called learning. Add whatever name you want, doesn't matter. Click far right to create cluster, start at free. So basically this button, meaning a free version. Then they give you a bunch of options where you can choose AWS. This is Amazon's like servers where you want the database to be hosted. Region Germany, this is closest to the Serbia, Romania, whatever, Estonia in Europe. And then wait for a little bit for the database to get set up. And now, basically, we have to be on this window here. It would say cluster 0. So basically, when you sign up, you can have multiple projects. Each project can have multiple clusters, and each cluster can have multiple databases inside. So basically, this is how their service is structured. So it doesn't matter where you initially sign up, you have a project, you get to this screen right here. If you can't find this screen, you can always go to your name, these breadcrumbs, and type of learning, whatever is the breadcrumb for your project, and then you would land on this screen right here. Then inside the cluster, you can click on collections, which will lead us to our actual database. Not just, it's kind of confusing, it says collections, but it's just a bunch of databases like this, like a blog database, and we can create many new databases we want within our cluster. You won't see anything here because you don't have any databases yet. So inside, now you can click on add your own in the box in the middle of the page, and here you will create like a database name, and you can, for the database name, put blog, for the first collection name, put posts. So how it works, remember that how I described the database. This is just like a server running on AWS servers, maybe somewhere in Germany, whatever. So it's like a API server, which, so that the entire database is like, the blog database is like a folder, and inside that folder we have a bunch of mini folders. And those mini folders are actually called collections. So each collection is like a subfolder within a blog folder within a blog database, technically. And each subfolder has many of these blog posts inserts into the database. So this is one blog post, this is one account, this is another account, this is another account within accounts collection, or the subfolder of the blog database. And each of these, consider them like a separate file, as we would store it on a PC, like ourselves. Just imagine it like that. So these are collections, accounts collection, posts collections in a blog database. So just continue following our setup tutorial here. So we essentially signed up for free. You don't need to put any card details, nothing. You created your initial database and a first collection, and that's it for this part here. Now, to be able to connect to our database, what you have to do is you have to create a role and attach a bunch of stuff to that role. So for example, imagine us having a database and very important details inside our database. And imagine us giving just like a generic URL so anybody can connect to it, anybody can delete anything, create anything in it, and so on. And imagine some of those people losing or leaking that URL and somebody just stealing it and just destroying our database. So that's a no-go. You don't do that. Maybe you have a couple of different people. Some people are just reading from the database. Some other people are just writing some stuff inside of accounts collection or just generic collections. But none of those people can delete anything, so they cannot delete anything, or they cannot delete the database as well. So that's why you need to create an account, and each account only has a certain role, and each role can have only a bunch of stuff it can do. So you can find, insert stuff, update documents, but you cannot delete the database, you cannot delete any collections, you can just add and read stuff. So even if somebody loses that their username and password, that leaks our link to our database, nothing crazy can happen in a way. Like we can immediately see that somebody stole it, nobody can delete any stuff. So that's why to access our database, you have to create a user. So you would have a username and password. You would add to the link of the database so we can connect to it as that. You can connect to it as that user in a more secure way. So basically, in the top left, you can click security and database. So basically here we have security and database access. And then it says custom role. You can click on a custom role, custom roles here, and you can add a new role. And basically to add a new role, you have to enter a database name. So it's a block database name, and then just follow the ones in the tutorial here. Find, insert, remove, update. So if I type find here, I would select it, and then I would add another, not here, sorry, I would add another action or a role. And again, it's for a block database, I can update documents in a block database. And just do a bunch of those rules and give it the name of like a developer. This is the custom role name. And just add all those rules you see listed here. And then click add a custom role here, and the role will be created. Now we have the database users. So then you can click add new database user, and you can add, I would suggest auto-generating a password and copying it from somewhere, and you can add a username as a developer. And then at the bottom you have select predefined custom roles, so the role we just created. And basically that's it. You would add a new user, and remember that username and password. That's very important. So here I describe everything I just showed you. Now, still we cannot necessarily connect to our database. So yes, we have a username and password, but we have to allow access to our database. So the database, so it's all different levels of security. So even like we can allow very specific IP addresses to connect to our database, not just anybody. But if you want just anyone to be able to access our database, or basically what it means that from any API we make, we can make a request to our database, then basically so you can go back to our cluster 0, click connect, allow access from anywhere, and then add a connection IP address. Click all those things, and then by doing all of that, essentially this IP address means it's public. Access to our database is public, but not public like anybody. You still have to send your username and password in URL in order to connect. But it doesn't necessarily prevent all the IP addresses from sending requests to it. Any IP address can send a request. You still have to send a username and password in the URL to connect to our database. This is just like a level on top, security-wise. So if you go back to our cluster, now when you click connect, you can click this thing here, connect your application, and essentially this is our URL. This is the URL we have to use to connect to our database. But look at this part here, password. So you can here put your username, and then the password you just saved locally. Don't share this with anyone. And once you put your password here and your username here, you just created, this link you can use inside of your API server to connect to your database. And from there on, we'll see how you can create some accounts, posts into your database, read stuff from it. But this is gonna be your URL you're gonna use to connect to your database. So the code to connect to it, you don't need to remember, you don't need to memorize. You can just copy what I just made, try to understand what's happening approximately, and basically that's it. And then from there you can just do anything you want with the database itself. So one trick before I want to show you is, so in a bit older JavaScript code, whenever people made some requests and then you had to wait for some response, or they used callback type of JavaScript code. So you call a function, you pass some parameters, and then you pass a callback function, and once the response comes, they call that callback function and give you whatever the response they got. So when you want to connect to your database, you pass the URL that we just got from the database with your username and password inside. You pass some options here, whatever, and you pass the callback function. So once this callback function is called, either there's an error connecting to the database, or you successfully connected and there's no error, and you can just say whatever details around your database connection is, so you can use your database. So now, this looks kind of awful because I hate these callbacks because it's nested. It's like it's a argument within a function. It's like, I don't like this JavaScript syntax at all. It looks kind of ugly. So remember, like async await that we used when we want to wait for a response in one line of code, and then as soon as we get a response, then we continue on executing our JavaScript. I really like that because it's a super clean syntax for JavaScript. It's all one line. It's a line of code to await for a response, and then we continue. It's all one lines of code. There's no like deeper nested JavaScript, a code within a code like this is right here. So I don't like it. So the way you can make it one line of code is we can use promises. And promises is basically, you can await for anything. Basically, we can create a promise right here, say promise equals new promise, and then you have to, the first argument is a function, and the argument is a resolve reject, and basically it's this. So now, inside of here, you can have this, you can connect to something and then await for a response, and like that can take a second, 2 seconds, 15 seconds, and only once you are officially ready to return a response from this promise, you can call a resolve function with some value inside if you want to, or a reject function. A reject function throws an error, essentially, and resolve function successfully resolves, returns some value. So if I say, for example, 1, 2, 3, and I say async function, I think I can await here, right here. Nope. Await promise, just promise itself. Yeah, there you go. I awaited for some response, but imagine something happening here inside the promise that takes some time, and we only call resolve once we officially get the response. So same thing here. We created a promise to connect to our Mongo. We created a promise, and it's a function that returns a promise. So once we call this function connect to Mongo, we officially trigger the connection to starting a connection to our database. That happens for a few seconds. Once we officially get it and this callback function is called, we get this client, which is basically like a door into our database, and then we store it in like an external variable like I did here. I mean, I did it just for this use case so I can show you how it technically works. And basically that's it. And the client is basically our currently running connection to the database. And you can type client.db, which is a function, and you enter database name, and that would be our direct database. This is our actual database. And to So basically we store it in like this Mongo object DB and client, so later down in the code, so we can await the connection. If the connection is successful, we store all of these things into our variable above, and then below we can just say Mongodb, and then again a function collection where you can type collection name to establish a connection to our database collection, and then you can just do whatever you want. So now you have these collection posts, this like this, and you can say find, which call a function which will find all your posts from a collection, and this .toArray method on the after find method basically turns the response from the database in like JavaScript, actual like a raw JavaScript array of objects, where each object is like an item in that post collection. So basically this is pretty much the syntax. You don't need to understand it too much, but this is the nice thing about promises, because we can turn this ugly line of code in like very simple await connect to Mongo method. It's like one line of code to await for a connection. Once the connection is officially established, then we can use our database, go into our collection, posts collection, find the posts, turn them into a JavaScript array of posts, and officially have all our posts we can return as a response to the browser app. Basically that's pretty much it. I can show you in the code itself exactly. Sorry. So the Mongo, here we have our lesson. So the example again is just a basic Express app. Don't get scared with all of this code. So remember that in the Express we only had a couple of things. We only basically used app use express JSON, only this line of code as a plugin, so we can handle incoming JSON data for like post requests. So the difference here is we added a bunch of other plugins. For example, every request gets logged if you use a Morgan. So we have like a bunch of different plugins. So I installed MongoDB, so that's a library to connect to our MongoDB. Then I installed cores, helmet, compression, method, override, Morgan. So you don't need to understand every tool like this. You can easily Google npm cores to see what it actually does and is. Just quickly, Morgan combine, any incoming request will get logged in the console to see who the request is coming from, what is the request targeting which endpoint, which is a method of the request like post, delete. Basically just logs it in the console. Helmet removes some things from HTTP headers and cleans up the headers a bit. The headers of the response that will get back to the browser app, blah blah blah. Compression compresses the request a bit, so the responses have less weight in terms of kilobytes, megabytes, whatever it is, so the communication is faster between a browser and a server. Method override, another security type of plugin, whatever. Cores, meaning that we can accept requests in our API from anywhere. Technically, incoming requests can be from any API address or any domain or any app, whatever. So these are just like plugins. All of this is just a bunch of plugins. And then if you remember, this is what we've done before. App get a route. We define like a root route and return some OK response, like this is the response, JSON response status 200 if you send us a request to this API endpoint. And then we don't necessarily just need to define routes with app.get. Another way to do it is called express.router. Basically encapsulate a bunch of routes under specific endpoint. So it makes sense once you start reading this. So if you do this router post and we say this router post, we are going to register it to use for any /posts route. So here this would mean we are creating a GET request for /posts. So basically /posts as a GET request will land here. So this is like a prefix for this router post for all the routes here. So if I added posts here, actually it would end up being /posts, right? So that's why this defined in a router post, because we already registered it for /posts. We just need to define get routes, post routes, that are building on top of this prefix. So /posts/ is just basically just /posts. So get request for /posts. We are gonna go into our MongoDB collection for posts. We are gonna find all the posts, package it in like an object, and then send it as a JSON response to our browser app. And then if you wanna write a post into the database itself, again, we can enter the collection of posts, get the request body, the JSON that you sent along with the request, the JSON about the post, like title, request body, whatever. And the one important thing is _ID is required for creating new inserting data into a MongoDB collection. So it needs this object ID is basically exported from when you require MongoDB when you basically use their library, they give you this object ID, which is a method that generates like a unique ID for each post. So this is required to have _ID to insert stuff, and then to method to call to insert something into a collection, which we can await. So I added a thing here. We can await collection.insert1 and then pass in that object inside the data. This is also called a spread operator in JavaScript. So basically it copies everything in the object that we got in a request body inside of this object. So basically transfers all the properties from whatever we send as a JSON body in this request, transfers all those properties and values inside of this data. This is how you spread it, like just move everything from that object to this object. And then additionally add the _ID. So basically this data we insert into a database and we just send a response back saying, it's created 200 successful requests. And basically we register these /posts routes. So now we have 3 routes. We have a root route and we have get /posts, and we have post request for /posts to create a post, and this returns all the posts. Basically that's it. It's just a bunch of more code, so don't get scared. Just read line by line and it's gonna make sense. And above all of that, this is just our API itself. And at the bottom we of course app.listen to port, and we start listening, basically turn on our server. But here we have a connect to Mongo, which is I explained prior. The code itself, we just await for it. We store all the Mongo client, MongoDB, client DB, make a connection to our blog database, and basically store it in this object. So again, later, once we await for a connection to Mongo, then we can use MongoDB, and then whatever the DB connection we stored here, we can then use it anywhere else in other routes. Just connect to that collection, read something from it, insert something into that collection, and that's it. That's pretty much it. But by the way, all this logic I stored in a run function, so I can put a thing here, so technically I can inline await connection to Mongo and so on. So one important thing is we only initially, once we start the server, we await for a connection, because we need a one single connection to Mongo in our server. We don't need to connect to our database on every single request that comes. That would be crazy. Like imagine getting like 1,000 requests a second and you create 1,000, and every time you have to connect to your database. That's just insanity. There's no need for that. You just connect to it once when your server starts, and then you start your server. You start listening. Why is this prior here? If our server, see, we throw a connection error. So basically this would break our server. If we start running our function and we await for a connection, and this connection actually throws an error, then by throwing this connection error in this way, throwing this error, whatever, if we throw this error here, because MongoDB failed to connect here, then our entire function will not run from here and on. It would just break and our server would not start. Because our server should not start if this connection isn't established. There's no point of our server running. So only if it successfully connects, then the JavaScript continues executing here, and then we listen to our server, call the function, our server starts, and then we can officially use our server. So basically I packaged all that logic in a function called run, and then I just called the function to start executing our server logic and connect to Mongo, we set up some logic for the 3 routes, we listen to it, and our server starts listening for incoming requests. That's pretty much it, and we can test it right now. So if I say Mongo, and I say go to the, I don't know where I am, so example, we have that folder, and if I say npm start, we are starting our Express server, and you can see that we log if the MongoDB gets connected. So if the MongoDB here is successfully connected, we console log it, so we also see it here, Mongo has connected. And by the way, one important thing is, you can store your MongoDB connection URL inside of a config file and just export that so you can import it in another file. So basically just a regular object, and it's not here, so in React it's export default something to export it, like make a default export for that file. Unfortunately, it's a bit more annoying in Node.js, so you would type module.exports equals this config. So by exporting it like this in this file, then you can import it in this other file like this, const config require config file, and it would return that config object. And then you can then use this like config.db.mongo.uri, like basically this, we store that URL in this variable, this config object. You're usually gonna have a bunch of config variables, so you don't need to hard code it all over your app. You can just put it in like a config object and just import that config object and just access those values where you need them in your app. This is just like to have a more cleaner, reusable code base. So once we did this, our server is running. So if we say get posts, it's gonna give us a response back of a bunch of posts I already created in my database collection. But if I wanna create some posts, I can make a post request, I can send some title, and I get a response that I wrote something in my database. So if I go back to get posts, I should see this created at the bottom. Yes, here you go. The title is some blog title, and this is the ID that's generated, just like a unique ID for my blog post. So this is what we just inserted into the database, and we went hit around /post as a get request to get all our posts, and it returned this one we just created now. Basically, that's pretty much it roughly for how MongoDB works. This is how we connect to it and how we interact with our collections in our MongoDB database, blog database, read something from, like, there's a bunch of methods how you can find something. You can make specific queries, say give me all posts back where the title starts with this, or where if it has tags which are A and B but not C, like you can make very complicated queries. This just returns everything from this collection, and this is how you insert data into a collection. There's a bunch of different methods you can use, but these are just simple ones to explain the principle of how you can use it, how you can use the MongoDB. But just with this alone knowledge, you can do so many things already. Like we already made a full app. This is our API server. It gives us some endpoints we can hit to read something from the database, read posts, create new posts in the database. We are using Postman, but the same way we are using Postman to do this, we can make a browser app to do the same thing, just from the browser app, from a React app. So technically, this is all the knowledge you need now officially to make like a full stack system. Like you have a database, you have a server to read stuff, posts from the database, create new posts, and then you send requests from your React app if you want to write some stuff into the database or read all the posts and show it on your home screen, and so on. So technically, we covered in a simplest way possible all the technologies and everything you need to be a web developer in a way. Of course, once we get to the final project next, we'll get into a lot more details, how you can build on top of all of this as additional sugar to make a more advanced and more useful API servers and more useful front-end apps. Don't get scared if once you, like, I don't expect you at all to even understand a smidge like of information once we start building this final project, but just try. And it's not gonna mean you are stupid, you're not for this. It's just, man, all of this I'm showing you is I distilled it down to like very few tutorials, but this is what I learned for like 3 years, gathered all this knowledge so I can simplify it for you in a simplest way possible. So it took a lot of time for me, but of course it can take a lot less time for you because I'm here to show you all of this stuff that I learned over a few years. But again, still it's a bunch of information. And again, when you look at all of these things individually, like API server, like, is this really hard? Like once you do this once, you can just copy paste it and you know how to connect to your collection, write things into it, read stuff from it. Like is it really hard? Like, come on. The amount of garbage we had to learn in even like elementary school, let alone like college or whatever, the amount of garbage information we had to like memorize compared to all of these simple lines of code for you to make an app, or even a React app, like you know how we did it. Like, it's not gonna change. We did it once like that, we are gonna do it another time the same way, just more advanced way. You know, it's fine. That's all the knowledge you need to make like full stack apps. Like if we memorized all this garbage from our school that makes no sense to us whatsoever, we just had to memorize it to get a grade. Like, why can't we just memorize this? Not even memorize, just try to understand what happens here, and basically what the tool is, what it does, how it communicates to the browser app, and vice versa, and that's it. And then once you do it once, you can copy paste it into a next project and just build onto it to be a more advanced developer over time. That's it. It's not that hard. Come on. Like, I really want to debate somebody who can tell me this is very hard, this is not for everybody, like nobody can do this easily. No, this is bullshit. Like, it can be very simple. Like, just once you do all of these things, like when you look at it all in one big pile, of course it looks scary. But once you go through each of these tutorials, each individual tool is not that hard itself, right? So you just do each part individually, and once they connect to each other all together, then you have like a full-fledged app, and it's really cool. But once you dedicate your focus to one tool at a time, tool individually is not that difficult or hard to understand. Like, I'm sure it's not. Just take some time to get used to all of this new information, accept it, this is how it works, this is how it goes, and then just start working on it. Just start testing, playing with it, and that's it. Okay, anyways, see you.